I'll record you. Go ahead. Okay, so now could you describe your justification here? How did you get from sine squared plus cos squared over cos to 1 over cos? So that was your Pythagoras identity. And then from 1 over cos to secant, reciprocal identity. Number 5, bracket 1 plus sine theta, all divided by sine theta. Prove that that is equal to 1 plus cosecant theta. We need to understand how fractions work. A single term in the denominator divides both terms in the numerator. It often simplifies things when you have a single term in the denominator to break. So you've got 1 plus sine all divided by sine. This means you've got 1 divided by sine plus sine divided by sine. Okay, so what is this? This is just basic algebra. Single term on the bottom divides both terms on the top. So I don't have enough room for my whole long explanation. And what is 1 over sine? It's cosecant. What's sine over sine? It's 1. How did I get this term? Well, this was just my reciprocal identity. So cosecant plus 1 is equal to 1 plus cosecant. I don't think I have to convince you that you can add in any order, and we're done. And sometimes they're just that easy. Most of your proofs are going to get way more complicated than this. This will just be one small step in a much longer proof. Okay, bracket 1 plus cosecant theta, close your brackets, bracket 1 minus sine theta, close your brackets. Prove that this is equal to cos theta times cotangent theta. So sometimes when you're doing a proof, you just need to do what it says here. That is, I've got 2 brackets being multiplied, and it's really hard to know what 1 plus cosecant and 1 minus sine are going to be, because notice it's not squared. Not squared. There's no Pythagoras in this. So I'm just going to FOIL this all out. Okay, so let's just FOIL out. That is 1 times 1 gives me 1. And 1 times negative sine gives me negative sine. And cosecant times 1 gives me plus cosecant. And a positive times a negative is going to give me a negative. One step. What is cosecant times sine? A function times its reciprocal. 1. Okay, we FOILed that out, and we used the fact that sine theta times cosecant theta has to equal 1. A function times its reciprocal is 1. Okay, would you collect like terms? One minus 1, still 0. I've got negative sine theta plus cosecant theta. And that doesn't look like at all what I'm trying to do. So when this happens, maybe we need to start working on the other side. Do you see that I've got 2 terms here and a single term here? Well, maybe I could write this as a single term. How could I add these two together? Well, they would need a common denominator. So let's give them a common denominator. I've got negative sine theta, and it's really being divided by 1, plus cosecant, which is 1 over sine theta. When you have a reciprocal function, you really have a fraction. Okay, so I just wrote cosecant as 1 over sine, so there's my reciprocal identity. And then I'm going to give them a common denominator. You're going to end up doing this a lot. Watch carefully. It's just like numbers. What is the common denominator? Sine. This already has the denominator. The only one that needs the denominator is this one. We're going to multiply by sine theta over sine theta. What am I going to end up on the top with? Negative sine squared theta over sine times 1, sine theta, plus 1 over sine theta. And if they have a common denominator, we can put them together. I'm going to reverse the order so you can see the identity we're looking for. I've got a positive 1, negative sine squared, all over sine. What is 1 minus sine squared? Grab your formula sheet. We've used this one so many times already, I'm hoping that you're starting to just see it without looking at the sheet. Cos squared. So I've got squared over sine. Okay, look at our goal. We're trying to get to here. Are we getting any closer? We got a single term. Why don't we work over here? So I said you can't cross the equal sign. What I mean by that is I couldn't multiply both sides by sine. I couldn't take the square root of both sides. I couldn't add or subtract the same number to both sides. But I can use an identity on this side. That is, instead of writing cotangent, I could go to my quotient identity. What's another way of writing cotangent? The quotient identity. That was the reciprocal. Yeah, cotangent's 1 over tangent. What's another way of saying it? It's cos over sine. Now do you see we got the same thing? So we've got cos squared theta over sine theta. Okay, we've got the left-hand side equal to the right-hand side. We're done the proof. Sometimes you manipulate both sides to get them to look the same. We'll do one more, last one, and then I want to see you guys do some work. So sine to the fourth theta minus cos to the fourth theta. Prove that that's 2 sine squared theta minus 1. Did we have a question? Okay, let's focus then. Okay, so when you're doing a proof, keep in mind what your goal is. So these are all to the power of 4, and these ones are squared. Can you think of anything that might help you here? Factor it. Good idea. So you basically have a difference of 2 perfect squares, don't you? So we know how to factor a difference of 2 perfect squares. If I asked you to factor a to the 4th minus b to the 4th, you guys could all factor this. A squared plus b squared and a squared minus b squared. Okay, same pattern here. What do we have? We've got sine squared plus cos squared times sine squared minus cos squared. It still looks complicated, but at least now we're working in squareds on both sides. Okay, so my description, what did I just do? I just factored a difference of squares. Do you see anything there? Jumping right out at you. What is sine squared plus cos squared? It's 1. Okay, so there's your Pythagoras identity helping you to simplify this. And you're just left with sine squared minus cos squared. Okay, so how did I do this one? Well, that was just my good friend Pythagoras helping me out. Okay, keep your eye where you're trying. You want to end up with 2 sine squareds, and right now you've only got 1 sine squared. In fact, I don't have to keep saying times 1, do I? Okay, so how do I get from 1 sine squared into 2 sine squareds? Well, let's start with the one that I've got, sine squared theta. And I need to subtract a cos squared. Is there a way I can write cos squared differently? Well, back to Pythagoras. Another way of saying cos squared is 1 subtract sine squared. So instead of writing this cos squared, and remember you're subtracting it, I'm going to say this is 1 subtract sine squared. Distribute the negative, and you're going to get -1. And a negative times a negative gives you another sign, so I've got 2 sine squared theta equals to sine squared theta minus 1. And done. Your homework is in your packet, and there's a bunch of